Alright, it's been a little while since I've made one of these, so here we go. This is for the geometry class. This is going over Circumcenter, so this will be your guys' review heading into the quiz that you're going to have on Monday. The only thing that's going to be on the quiz, it's going to be just like that handout that I gave you guys in class. It's just going to be over Circumcenter, so I'm going to give you the coordinates. This is the same example that is on the worksheet that I gave you guys. This is actually the same example that I did in class when we first introduced the concept. I'm going to walk you guys through the steps. I am going to speed up the video in a couple of spots so you're not just watching me scribble at various points. So on the scratch word sections, you will see the you'll see the video speed up there. Just follow along. I'll give you guys your steps here, and it is broken down. The quiz is broken down just like the handout I gave you guys in class. All right. So step number 1. Okay. The very first thing that we're going to find is we are going to find the slope for each of the side lengths for our triangle. So this makes 3 triangles. At the very end of the video, I'm going to do this on GeoGebra so that you guys can see what the graph looks like. But for our purposes here, we know we're going to have 3 side lengths. Let me try this light. It's a light glare. Is that better? It's a little bit better. Okay. So on GeoGebra, you guys will see you'll see the actual graph of what's going on. But ultimately, what we are doing here is we are going to we need to find the slope for side length AB. That's going to be using these 2 points. We need to find the slope for side length AC. That's going to be these 2 points. And then we need to find the slope for side length BC, which will be these 2 points. So go ahead and do that. The slope formula, if you guys don't remember, slope is equal to y2 minus y1 over x2 minus x1. Alright, this will not be given to you guys on the quiz. You must remember this one. I will give you the midpoint formula. I'm not going to give you guys the slope formula. So go ahead and take a few minutes here. This is where the video is going to speed up, and you guys will see me put together the slopes for these 3 points. Alright, so that's our first step. First step is always finding the slopes. Okay, the slopes for each side length. The second part of what we're going to do here, let me change colors here. The second step we're going to go through is finding the midpoints for each side length. I will give you this formula when we do this on the quiz. That formula is the sum of the x coordinates divided by 2. That'll give you the x coordinate for the midpoint. And then the sum of the y coordinates divided by 2. So we will have the midpoint for segment AB. We will have the midpoint for segment AC. And the midpoint for segment BC. So go ahead and figure that one out as well, and the video will skip forward again. Alright, there we go. So here are our 3 midpoints. So we've got 1, 4, 4, 4, and 3, 2. So we've done most of the most of the work that we need to do in order to do this. Now it just comes down to kind of organizing some of our thoughts so that we can do step 3, which is finding the perpendicular lines that go through each midpoint. Alright, so if we go back just a step here for a second, if we look at these 3 here, these are the slopes that we have for our original side lengths. What we're going to do is we need to find the negative reciprocal for each of those. 2 is the same thing as 2 over 1, so the negative reciprocal, the reciprocal will be 1 over 2, and then we multiply it by negative 1 to get the negative reciprocal, so we end up with a slope of negative 1/2. Negative 1 is the same as negative 1 over 1. We flip that over, we'll end up 1 over negative 1. Multiply by negative, we just end up with 1 over 1, which gives us a slope of 1. And then this one is 0 over 1. 0 over 1, that's how we get horizontal lines. So when we have a horizontal line, the perpendicular to a horizontal is a vertical line. That vertical line is going to be determined So hold on a second, let's go back here. So the negative reciprocal of 0 over 1 is an undefined slope, which means we're going to have a vertical line. The vertical line in this case is going to be defined by the x-coordinate of the midpoint. All right, let me grab another sheet of paper here, and then we are going to look, well, actually, we can do them here. Why not? Okay, so let's look at the perpendicular line for AB. So we're going to look at the perpendicular line of AB, and it's going to go through the point 1, 4. So we're going to start off with y is equal to mx plus b. We know the slope, since it's perpendicular, will be negative 1/2. So we will have y is equal to negative 1/2 x plus b. We know it must go through this midpoint, so we're going to plug in this for our x and y coordinates. So we will get 4 is equal to negative 1/2 times 1 plus b. That'll just give us a negative 1/2 on the side. We will add 1/2 to both sides, and that'll give us 4.5 will be equal to b, which gives us a final equation for our line of y is equal to negative 1/2 x plus 4.5. Or 9, it's 9 over 2 is the other way of looking at this. Okay. There we go. So there's our first perpendicular. Go ahead and do it for the next two. The next one will be, again, the video is going to speed up. We're going to do it for the perpendicular for AC, and we will do it for the perpendicular for BC. Okay, go ahead and find those two. Alright, so we've got our three perpendicular lines here. We have the first one that I solved with you guys. The second one you guys had to do on your own. Start with y equals mx plus b. We plugged in the slope that we found earlier. Which was 1. Then we plugged in the 0.44, which is the midpoint. Multiplied it out, we get 4 is equal to 4 plus b. Subtract 4 from both sides, we get 0. So y is equal to x is the perpendicular line in that case. And then also from earlier, we had the undefined slope from our horizontal line, which had a slope of 0. The undefined slope is the perpendicular slope, which means it's going to be the x-coordinate of the midpoint. The midpoint was 3, 2, which means our perpendicular line will be at x is equal to 3. Alright, so flip this over really quick. So the last part that you guys will be asked to do, we'll do the graphs here in a second. We'll do the graphs after I do this next part. The last thing you guys will be asked to do is you'll be asked to confirm or find the midpoint using algebra. So the way that I'll ask you to do this is I will identify the two lines, because you'll have one that's going to be equal to like x equals 3 or a y equals something. So you'll have one of the horizontal or vertical lines. I don't want you using one of those. I want you guys to kind of have some practice working with some systems here. So we're going to take the two y equals lines, and I'll do this on the quiz as well. Take these two lines, and I want you to set them equal to each other. So we will have y equals x, and we have y is equal to negative 1/2 x plus, this was 4.5 here. You might remember earlier I said this was the same as 9 over 2. I'm going to turn it into 9 over 2 for the purposes of solving this problem. We know from the reflexive property, that y is equal to y. Well, these are both equal to y, so we're just going to set these each equal to one side of the equation. So we will get x is equal to negative 1/2 x plus 9 over 2. So we're going to solve this for x now. The video is going to speed up again. Get rid of the denominator, multiply everything by 2, and then isolate x. Alright, so we found that x is equal to 3. That's good. We know that y is equal to x by one of our earlier, by one of the lines that we found here, which actually acts like an identity for us. We know that y is equal to x. We know x is equal to 3, so that gives us the point, a coordinate pair of 3, 3 for our circumcenter as the intersection of these two lines. So this is the circumcenter of the triangle. Alright, do remember that the circumcenter of the triangle is equidistant from each of the vertices of a given triangle. So we're able to draw a circle centered at the circumcenter that will touch each of the points of the triangle. I'll show you guys that here in just a minute. Alright, so this is the triangle that we were working with. Let's double check all of our points here. We have A was at the point 2,6, B is at the point 0,2, and C is at 6,2. So let's run through all of the information we have here. So we have that the midpoints were at, so the slopes of the lines, we only really use that to find the perpendicular slope, so we don't need to worry about that part so much. Let's take a look at the midpoints. So we have a midpoint at 1, 4. Let's type that in. So we have 1, 4. This is our point C. That looks to be right in the middle of segment AB, so that one looks good. Our next point was at 4, 4. Okay, that looks to be, that's this point E right here in the middle. That appears to be in the middle of this segment AC. And then our last midpoint was at 3, 2, which is right there in the middle. So we also found our perpendicular lines, so we can plug those in. We'll start off with x is equal to 3, so x equals 3. That generates this vertical line at x equals 3. That looks good so far. Our next one was y is equal to x, so y equal to x. Oops, what was that? Stop. Y equals x. There we go. Alright, and that generates that line. Now we really only need to find 2 lines in order to find an intersection point. This point right here in the middle. But I'll go ahead and graph the third line just so that we have it for completeness purposes. And that was at y is equal to negative 1/2 x plus 4.5, or 9/2, so 4.5. Okay, and there's our last one. And all 3 lines intersect at a point, which we will identify here. They all intersect right here at this point that is listed as G here, which is at the point 3, 3, which if you look back on the scratch work that we did when we were solving the 2 equations for each other, 3, 3 is the same point that we found for our circumcenter when we did it algebraically. So this point GG right here, this is going to be, I'm sorry, this point 3, 3, this point is going to be the circumcenter of our triangle. And we can check that. We have this property, you guys won't have to do this part, but I just want you guys to see it. And that is that the distance from G to B, each of these, and then the distance from G to A, and then the distance from G to C will be the same for all 3 points. If that is true, then we can draw a circle that will centered at G that will touch all 3 points. So this is that circle theoretically, and we center it at G, and we see that it touches all 3 points A, B, and C. You guys won't have to draw this circle part. You guys just need to find the circumcenter, but know that this is a property of the circumcenter of a triangle. Alright, that's everything you guys need to know. So again, I will give you guys the midpoint formula. I am not going to give you the slope formula, and you need to know the properties, the special characteristics of the circumcenter, which is that it is equidistant, or it is the same distance away from each of the points of a triangle. And also know that the circumcenter is created by the intersections of the perpendicular bisectors of each side of a triangle. Alright, there you guys go. I will see you guys in class.